Hey guys, welcome to Absolute Value Day 2. Okay, so yesterday we talked about absolute values. Today we're going to discuss some inequalities and what those mean. The best way that I can think about the less than is the and effect. So I like to say less than when I talk. I'll say that, than, so that I remember when I'm talking about my absolute value inequality that it's less than, and that means I have an and inequality. Okay, so in the inequality absolute value of x is less than 5, what numbers is that true? So think about what numbers would make that true. So I'm going to think about if I drop the bars, that would be anything where x is less than 5, or anything where x is greater than a negative 5. Okay, so think about that. If I were to graph that on a number line, this would be between negative 5 and 5. Okay, so in between less than 5, greater than negative 5, and it does not include those numbers. So remember, if we graph with our interval notation, that's just a set of parentheses. Okay, so we're going to start with solving less than absolute value inequalities. Okay, so we're going to rewrite the inequality. Looks like this. So for my example up top, it would be negative 5 is less than x, which is less than 5, which is how most of you guys are used to seeing the and inequalities. Then you're going to solve if necessary and graph. Okay, so my first example says the absolute value of 2x plus 7 is less than 5. So we're going to rewrite it with a negative 5 less than 2x plus 7 less than 5. Remember when you solve and inequalities that you have to do everything to all three pieces. So I now have a negative 12 less than 2x less than a negative 2. And then when I divide by my 2, I get negative 6 is less than x, which is less than negative 1. Okay, remember when we write this as our interval notation, it looks like negative 6 to negative 1. Okay, which on my graph, negative 6, 5, 4, 3, 2, 1, is going to look like parentheses. Okay, remember if you were doing the old-fashioned graphing, those would be open circles and you would shade in between. Okay, example number 2, we have negative 3 is less than or equal to 5 minus x, which is less than or equal to 3. So all you're doing is making this negative over here, positive over here. And then we're solving. So I'm going to divide subtract 5 from each piece. So I have negative 8 less than or equal to x, negative x less than or equal to negative 2. Okay, and now I'm going to divide everything by a negative 1, which remember does flip my signs. So this is actually backwards from what we like to see. So we're going to flip everything. 2 is less than or equal to x, which is less than or equal to 8. Remember that that would be a bracket 2 to 8, and then a bracket around 8 as well for interval notation. So when we graph that, 2, 3, 4, 5, 6, 7, 8, I want to make sure that I am going to put brackets at 2 and 8, and they should face each other because we would shade in between if this were old school. Okay, let's think about this. What if a is a negative real number? So if absolute value is less than a negative number, what does absolute value mean? Remember we talked about this. Absolute value of 3 was 3. Absolute value of negative 3 was 3. So we should be getting positive numbers every time. So this example says my absolute value is going to be less than a negative number. Okay, so if the absolute value is less than a negative number, the answer is always no solution. I should get a positive number for absolute value, so it should not be less than a negative number. No solution. Okay, now we're going to talk about the greater than effect. Okay, so in the inequality, for what numbers is this true? So we want our absolute value to be greater than our number. Okay, so think about that. When would that always be true? So my absolute value is greater than a number. What if this is a negative number? Okay, is my absolute value always greater than a negative number? Okay, the answer would be yes. So it will always be true when it is greater than a negative number. Okay, then it says, will it always be true for an absolute value greater than a positive number? Okay, so if I just have my absolute value is greater than a positive number, it will not always be true. Okay, so we're just going to solve and figure out when it would be true. So that's where our solving steps come in. Okay, so this should say, oops, right here, this should say greater than. So fix that on your notes. Steps to solving a greater than absolute value inequality. So this is for when A is a positive real number. So we're going to rewrite it in two separate inequalities. So we'll have x is greater than A. So for this first one, you just drop the bars. Okay, the second one, we flip the sign and drop the bars. Okay, and A is negative. Then we're going to solve and graph. Okay, so our example says 3x minus 2 inside an absolute value is greater than or equal to 4. So our two equations look like 3x minus 2 is greater than or equal to 4, or 3x minus 2 is less than or equal to negative 4. And now we need to solve. So I'm going to add 2 to both sides. I get 3x is greater than or equal to 6 divided by 3. So x is greater than or equal to 2. Or when I add 2 to both sides over here, I have 3x is less than or equal to negative 2. And when I divide by 3, I get x is less than or equal to negative 2/3. Okay, think about how we wrote this in interval notation. So x is greater than or equal to 2. Okay, that one looked like bracket 2 to infinity, or was where we had that union, that big U. And then our other inequality, x is less than or equal to negative 2/3. So this is negative infinity all the way up to negative 2/3 with a bracket. Okay, so when we graph this, okay, we're going to have a negative 2/3 on our graph. Okay, remember that would have been a closed circle. So make sure with our new graphing that you are putting a bracket. The bracket faces the same way that it does when you write an interval notation. So notice down here with the negative 2/3, that's the same direction it's facing here. And our positive 2 up here gets that same bracket as our positive 2 at the bottom of the screen. Okay, so remember this is an or, so it'd be where you would shade out with the old school graphing. Okay, number 5, my absolute value of negative 3x plus 10 is greater than or equal to 2. So remember, for the first one, you just drop the bars and solve. So I have negative 3x is greater than or equal to negative 8. Divide by a negative 3. So I flip my sign. X is less than or equal to 8/3. Or I am going to flip my sign and make my 2 a negative, and then solve again. So negative 3x is less than or equal to negative 12. Divide by a negative 3, so flip my sign, and I get x is greater than or equal to 4. Okay, so on this side I have my negative infinity all the way up to 8/3, or x goes from 4 to infinity. Okay, so remember that if you're not sure about fractions, you can plug that in. So think about what 8/3 would look like as a decimal, if that helps you. So this would be 2 2/3 for my first one here. Remember, it faces the same direction that it does when it's in interval notation. Then I have my bracket at my positive 4. Okay, last thing, what if a is a negative real number? So my absolute value is greater than negative 5. Okay, think about my absolute value should always be a positive number, right? So absolute value would always be greater than a negative. So this is always all real numbers. Okay, remember, so that's where it would be negative infinity to infinity. So my examples down here, number 7, absolute value of 3x plus 5 is greater than a negative 6. This would be your all real numbers. And number 8, my absolute value here is less than a negative number, negative 4/5. So this one is a no solution. So greater than a negative number is all real numbers. Less than a negative number is no solution. Bye guys, and I will see you on Monday.